them, assign numbers to the 200 of them. And when you assign numbers to the 200 of them, you can use your computer to generate, to randomly select a number, some numbers, and pick the people who correspond to those numbers. The problem a lot of time though, is that it is very, very, very difficult to find all those numbers. And even if it is not difficult, sometimes it is not feasible to go find all those people. Sometimes you are living in a city where it takes hours and hours and hours to get to some facilities within the city. And because of that, you cannot just go to just going around to each of the facilities, finding every single person. So because of this, there's a variety of ways in which people have, devised to still select a random sample, but that is not just a simple random sample. The kind of sampling that I described just now, which is get a list of everybody's target population and select randomly from that list. That will be a simple random sampling, and that will be the most accurate, from a theoretical viewpoint, the most accurate sample that you can get for your estimate to approximate what you would get from the target population. But that's just not feasible so many times. And because it's not feasible so many times, we do other kinds of sampling. One of the other kinds of sampling that some of the contributors earlier have hinted at is what we call a systematic sampling, which is that you figure out one person from the list, and then you select people at nth interval from that person until you have your full list. Say everybody in the sample is 500, and then you start from number 10, and you want to select five people. You can start from number 2 and select someone at the at every 100th interval. Now, the problem is that, so that's what systematic sampling is really about. But systematic sampling is not, it's better than just a convenient sample, but it doesn't necessarily guarantee randomness, because the person at the nth interval depends on where you start. And because you determine where you start, if you do not introduce randomness in the determination of where you start, it might end up not being a random sample. So for a systematic sample to have that element of randomness that you want, usually what we would do is use a random process to determine where the starting point would be. Whether you want to start from number 1 or number 7 or number 8 or number 10, when you use a random process to determine that starting point, and then you select everybody at an nth interval from that starting point, you can have something that's much closer, that approximates a random sample from a systematic sampling process. Now, sometimes when we look at a study, we're interested in certain subsets of the population. So for instance, I'm looking at the Lagos, we're interested in knowing the gender distribution among physicians. We're interested in knowing, for instance, we're interested in knowing the age of physicians or public health scientists in Accra. We can as well just get the list of all the public health scientists in Accra and do a simple random sample. That would work. But sometimes we're not just interested in, say, the age of everybody, all the public health scientists. Sometimes we're interested in knowing the age of women and the age of male public health scientists, as well as the age of female public health scientists. If you do a random sample, if you're not careful, you might not have enough people in your sample who are males or who are females, depending on what the population in the target, what the distribution in the target population is. So one way of ensuring that you have enough males and you have enough females in your sample that you want to study is to say, well, don't let us just do a simple random sample. Let's do what we call a stratified random sample, meaning that let's stratify the general population, the target population, into 2, males and females. And then let's do a simple random sampling among the males and a simple random sampling among the females. And those who are selected from the males and those who are selected from the females would form our study population. The essence of doing a stratified random sampling is to ensure that all the strata of interest are included in our study population. Another kind of sampling that that you see that people often do is cluster sampling. Sometimes cluster sampling, the decision to use cluster sampling is being driven by practicality. So here is the thing: for instance, we're interested in, what is the, say we're interested, for instance, say we're interested in the occupations of women who come from ANC for ANC clinics in a place like Lagos. One thing we can do is to say, let's find a list of all the women who are going for ANC clinics, who are attending ANC clinics in Lagos, and do a simple random sampling. For many reasons, that's a very difficult thing to do. To find the women, to go around looking for them, that's a difficult thing to do. Someone might say, why don't we just do this? Why don't we just sample? Okay, someone might say, why don't you just sample healthcare facilities? Get a list of all the healthcare facilities and do a random sample from the healthcare facilities. And when we do a random sample from the healthcare facilities, we might just go to the healthcare facility and say, okay, you guys, I mean, for the selected healthcare facilities, say we select like 20 healthcare facilities from the list of healthcare facilities in Lagos, and we can then talk to those 20 healthcare facilities and say, give us the list and occupation of all the women who are attending ANC clinics here, and let's compute how many of them are nurses, or how many of them are whatever we are interested in. In essence, the unit of sampling in a cluster sampling is a cluster, not the individual participant. So when we sample for healthcare facilities, for instance, not for the individual woman. Now, cluster sampling is related to another kind of sampling that is called multi-stage sampling.
Okay.
But what happens in multi-stage sampling is that we do not just sample the clusters and aggregate what we get from the clusters. After we have sampled from the cluster, we also sample even within, we go further and still sample within the clusters. So for instance, we sampled 50 hospitals in Lagos. And these 50 hospitals in Lagos, we did not stop at that. We asked them for a list of the participants. We still go further to sample randomly in each of the facilities, sample among the participants in each of the facilities. That's what is called multi-stage. The primary sampling is what we did initially, where we sampled the healthcare facilities. There's another secondary sampling which is happening within each of the facilities. Sometimes you might have up to 3 stages, like we have in the DHS. Sometimes when you want in sampling the actual units that will be included in your study population, where you're doing a multi-stage sampling. There's a problem that arises from the multi-stage sampling, and I don't want to dwell so much on this, which is that the probability of inclusion in your study might be different for different people. That might be the case even in cluster sample also, because here's what happens. The healthcare facilities are not the same size. In some healthcare facilities, you have 20 people included, you have 20 people attending ANC. In some healthcare facilities, you have 200 people attending ANC. So you say, for instance, in your multi-stage sampling, you might say, let's select 50 healthcare facilities. From the 50 healthcare facilities, let's randomly select 10 women from each of the healthcare facilities. In the facilities where 200 women are attending, you're selecting 10 out of 20. The probability of each woman getting your sample is 1/20 for that level of sampling. Whereas in a facility where there are just 10 women attending ANC, virtually everyone is guaranteed a seat in your study sample. So to address this, sometimes to follow certain procedures that ensure that the probability of sampling every individual unit is proportionate to the size of that unit. And at the end of the day, the at the end of the day, the probability does not equal out, but the chances of the probability of each woman getting into the sample becomes much closer to one another than what you would have had if you had done just a multi-stage sampling that did not take the size of the units into consideration. So I think we're going to move on from design approaches right now. So I'm just going to move on from these slides because I've spoken a lot. I've talked about what's essentially involved here, and we're running out of time.
If you want to take a break, this might be a good spot to take a quick break.
I think we should.
Yeah, we can take a 5-minute break and then come back.
Hey guys, it's Filler Friday. We are now offering.
So I guess we can get started.
So, can we go ahead? Can you hear me?
Yeah, we can go ahead. I can hear you, yes.
Okay, so you're welcome back. So essentially, we've just talked about random sampling and other types of sampling. We've talked about the rationale, why sampling is very important, and the implications of having a good sample. But here's the problem. Having a random sample so many times is very difficult, it's very costly, and sometimes, quite frankly, it's just infeasible. And there are many studies who use confidence samples. Sometimes you find people describing confidence samples as random samples, sometimes because they are not very clear conceptually about what a random sample means. But at other times, they treat confidence samples as random samples just because it's convenient. So we have to bear in mind, even if we're forced to use confidence samples where we should have used random samples, we have to bear in mind this limitation. And we have to understand that a lot of the statistical procedures that are going to be taught in subsequent classes or in this series actually assume that the sample that you have is actually a random sample. So we have to bear in mind that limitation, and that misspeak between the actual data that we have and the theory backing the statistical analysis that we're applying to that data. So now I think it's full time.
So because of the all shifting that we did from the webinar to here, we will not be able to have the poll that the way we had set it up.
Wow.
Yeah, so right, so we couldn't transfer it from there.
That's okay. So I think what we're gonna do is, but at least people can see the polls from their location.
You can see it on the screen here, and then you can have a few people come up and speak.
So that's what we're gonna do. So you're gonna have the next 60 seconds to read through the polls, and we're gonna have some conversation around the question in the poll. So you want to estimate the average waiting time for women attending 25 antenatal clinics in your district. And you have a list of all the women. Which of the following sampling approaches will yield a sample that is probability-based? A, listing the names of all ANC patients in all 25 clinics together in alphabetical order. Select the first and then select every 20th name. Using computer-generated random numbers to select 10 clinics, and selecting the first 15 patients that enrolled from each of the 10 clinics, using a roll of dice to select 5 clinics, and using a roll of dice to select 10 patients from each of the clinics. Administer the questionnaire to all women that attended ANC in each of the clinics in January, B and C. So can we have volunteers who want to tell us their answer and tell us why they chose it? Volunteers. So, yeah. So we're gonna have 2 to 3 volunteers on this, depending on the way conversations go. Toluwani.
Okay, good evening, everyone. I'm Toluwani from Lagos, Nigeria. So I think the one that we need a sample that is probability based is the third option. That is using the roll of dice to select 5 clinics, because then it is possible that any of the 25 clinics is selected. And also within those clinics, using the roll of dice to select 10 patients from each of the 5 clinics. So because then we're also giving everybody in that within the clinic equal probability of being selected. So I'll go with the third option, C.
Is there a reason why you didn't choose A?
A. Okay, with A, because the starting point is, we are not randomly, the starting point is not randomly selected. We just said the first name, and then every 20th name. So because we did not randomly select that, the first name, it's going to affect we did not give everybody an equal chance.
Okay, thank you, Toluwani. That's exactly accurate, and thank you for your contribution. So, Betsolo.
Thank you very much. I think I will go with E, because
Okay.
if we look at the response, there is a sort of giving chance of being selected. There is a sort of randomness that is using computer to generate random number to select 10 clinics and then selecting the first 15 patients that enroll. There is a sort of randomness that is the risk of introducing bias is reduced at this level. Then if we also look at using a roll of dice to select 5 clinics, then using the same roll of dice to select 10 patients without actually knowing them, then there is a randomness. So this will be probability based. So I think I'll go with E.
Thank you, Betsolo. Where are you speaking from?
I'm speaking from Nigeria.
Okay.
I'm a vet epidemiologist.
Okay. Is there someone else who wants to contribute? Then thank you for your contribution. That's very helpful. Yes.
Please, can I come in?
Say that again.
Please, can I come in?
Who is that?
Okay, I'm Justice calling, talking from Ghana.
Yeah, absolutely. I'm just asking for your name. I'm asking for your name. Go ahead.
Okay, I will go with the E, B, and C, because looking at the B, the researcher is not in control of the selection that will be carried out. And here, the bias is reduced. Looking at the C2, we can also see that here the researcher is also not in control of the selection of the clinics, neither is he in control of the selection of the participants. Unlike the A, which the researcher is in control in selecting of the participants. So I think I'll go with the E, the B and C.
Is there someone else who wants to contribute?
Yes, please.
One more. Okay, go ahead.
I think it's in response to what the other person said about eliminating bias in the second option. And I think that doesn't, I don't know, maybe I'm wrong, but I just feel like selecting the first 15 patients already introduces the bias of that, especially if the first 15 patients were put there by in an order, maybe those that registered first or maybe alphabetically or something. If you're now selecting that first 15, you don't give the ones, the rest of the ones on the list an opportunity to be like randomly selected. That's what I just think. So my initial response was a C, and it's still a C. I'm just, maybe you can give more clarity on the bias in what I've just said.
So thank you very much. I think we were going to limit conversations now. There's still several subsequent polls that you would have the opportunity to contribute to. But yes, the answer here is actually C. And everybody who's contributed, the good thing about our contributions is that it looks like we're actually thinking about the processes that we've talked about here. Number one, the first thing we should notice is that in all 3 cases, these are not simple. So I think the first one is B and C are multi-stage sampling procedures. In C, for both stages, we have a random process that is being used to generate items, units in each of these two stages. Clinics, patients, both of them, we're being selected with a random process. B, I agree with those who have said that in B, there's a reduction in the kind of bias we have because we have randomly selected the 10 clinics. But at the second stage, selecting the first 15 patients, remember the example we talked about when we wanted to figure out how many physicians were in this class. If we select the first 15 people, the first 80 people to log on today, we might get a sample that does not represent our population. Why? Because today, people who are particularly very busy today might end up not getting into this class because of the glitch we had with the technological glitch that we have. So sometimes we know we're able to know that today is not a good day for the selection because we know of this glitch. But here's the thing: there are so many glitches in real life that we actually don't know about. So to select based on the first 10, the first 15 is not a random process. It's a convenient process. And even though the 5 clinics, even though the 10 clinics were randomly selected, just conveniently selecting patients at the second stage of selection can introduce bias and can, and you can end up having a sample that is not representative. So the answer here is C, and I hope that's clear to everyone. You can, if you still have further questions on this, you can write questions. Dr. B, people can access the chat, right? So you can put, if you have further questions, you can put that in the chat, and then and we'll deal with that later. But I hope this is at least clear to an extent. We would have more opportunity to talk about this as we move on. So now I'm going to talk about how do we move from actually estimating statistics from our sample and linking that to parameters in our target population.
I just want to say, sorry, quickly, that we have seen this slide in the last class. It's okay.